Good morning, dear students. Today we are going to see about a new chapter which is carboxylic acids. In this chapter, we will see today what are carboxylic acids, and then we will see what is the acidity of carboxylic acids. So carboxylic acids are organic compounds which contain one carboxyl group, that is COOH, where hydroxyl group OH group is directly attached to the carbonyl group. If you see the structure, this is the carboxylic acid group where C double bond O carbonyl group and OH at right side. Or this also can be represented CO2H, or it can be represented with COOH. All these three format or in three ways carboxylic acid group can be represented. Now, carboxylic acid constitute most frequently and present in the organic compounds in nature. They are present in peptides, they are present in proteins, enzymes, etc. So now, what are the properties of carboxylic acid? So the physical properties of carboxylic acid can be explained from the perspective of bond polarization in the carboxylic group and its capacity to engage in hydrogen bonding. So carboxylic acid, as we know that it has the carboxylic acid group and OH group, and this OH group is a polar nature. So hydrogen releasing property or binding property with oxygen and this hydrogen. So the polarity of this carbonyl, based on this polarity of carbonyl group and hydrogen bonding properties or capacity, the carboxylic acid properties can be explained or they can be given the extent of acidity. So the carboxylic acid usually boils at considerable higher temperature than alcohols because they are the corresponding alcohols. So they are higher than alcohols, ketones and aldehydes with similar molecular weight. For example, if you see the example here, 2-methyl-1-butene, it is alkene which contain the 5 carbon, whereas butane 2-ol, it is also it is 4 carbon, then butanol, butane 2-ol, then propanoic acid. So these are the 4 compounds where we can see the boiling point is increasing from 31 degree to 141 degree. Carboxylic acids are having higher boiling points. They are stable compounds and these carboxylic acid boils at higher temperature due to presence of this particular carboxylic acid group. Now, if we see the carboxylic acid capacity here, the carboxylic acid OH hydrogen will bind with the another molecule of carboxylic acid, that is hydrogen bonding. So this hydrogen bonding, it is an intermolecular attractive forces will make this molecule to be more stable. There it has higher boiling points. The high boiling points of carboxylic acid is attributed to their capacity to readily form stable hydrogen bonded dimers. Now, acidity of carboxylic acid can also be explained when this carboxylic acid is converted into carboxylate ion and hydrogen ion to release of proton, and then formation of carboxylate ion will be the measure of the acidity. More easily, more frequently, the hydrogen release, proton release, carboxylate ion form, it is a more strong acid. If you see the carboxylic acid, release the proton H plus ion and convert the carboxylate ion where oxygen of the carboxylic acid contain the negative charge. If you see the acid dissociation constant, then it has high Ka value, that's why it is a strong acid. If it has a low Ka value, constant dissociation constant, it has a weak acid. When it comes to the pKa, pKa is equal to minus log Ka. So when we see the high pKa, it is a weak acid, where is a low pKa, it has the high acidity or highest acidity. Now if we see some example of these compounds, If you see the ethanol, which is a acidic in nature, OH, proton can be released, protic solvents, and phenol, which is also a proton releasing compound, acidic in nature. And then we will see the acetic acid, which is a carboxylic acid, and then one mineral acid, which is a HCl. So if we see the pKa values, the ethanol has 16, whereas phenol has a 9.89, and acetic acid has 4.76, and HCl has 7, minus 7. So in this case, highest the pKa value, the weaker the acid, lowest the pKa value, strong is the acid. That's why HCl, which is a mineral acid, is a strong acid, and carboxylic acid is acidic in nature, whereas the phenol and ethanol, they are weak acidic in nature. Now, if you see the hydroxylation of this thing, when it undergoes hydro reaction with water, it converts into hydroxyl ion and carboxylate ion, and here the dissociation constant and pKa can be calculated from this equation. Now, some of the pKa values and Ka values are given for some common carboxylic acid. First is trifluoroacetic acid has 0.59 Ka, whereas pKa is 0.23, whereas formic acid 1.7 into 10 to the power of minus 4 Ka, and pKa is 3.75. 2-hydroxy acetic acid, it has 1.5 to 10 to the power of minus Ka, then pKa is 3.84. Benzoic acid has 6.46 into 10 to the power of minus Ka, and pKa 4.19. Similarly, when we come to the ethanol, it has a 1.1 into 10 to the power of minus 16 Ka and 16 pKa value. So we know generally that lowest the pKa value, highest the acidity. That's why the trifluoroacetic acid, which has the lowest pKa value 0.23, that's why it is a strong acid, whereas the ethanol, which has the highest pKa value 16, it has the weak acidic character. So with this, we have completed today the introduction about the carboxylic acid and their acidity. Next class, we will take the other part of this thing. Thank you very much.